More and more embedded devices and sensors are connected to each other and to the internet. Then the devices can be remotely controllable and their data accessible anywhere using any kind of devices the users might have. This is the Internet of Things. However, as exciting as all the new innovations around this are, the complexity for creating embedded systems along with the technical requirements for setting up these systems and their backends has increased dramatically. The Qt weather station is a simple implementation of Internet of Things. It features these weather stations all equipped with wireless weather sensors connected to an embedded device. The device is connected to Qt Cloud, where it streams the data along with showing it locally on the device. From the Qt Cloud, you can access the device data from any mobile device or desktop PC.
My name is Andy Nichols and I'm a software engineer at Digia. So I was responsible for writing the C++ backend for the embedded device that runs the weather node. So the embedded device is responsible for communicating with the weather sensors via USB. It takes this data and it puts it into a JSON object and displays this in the local UI as well as in Genio data storage. I'm using the Raspberry Pi, which is flashed with the pre-built software image that comes with Qt Enterprise embedded. This way I can use the pre-configured Qt Creator ID to deploy directly to the Raspberry Pi and immediately see my software running on the device. Because I'm using Qt, the details of the platform don't really matter. I could just as well be writing a desktop software and yet I'm writing embedded. So the implementation details were actually rather easy. Qt had already taken care of the details, I just needed to implement the content.
My name is Mitch Curtis and I'm a software engineer at Digia. I wrote the UI for the weather client. The client runs on embedded desktop and mobile devices. We had a designer for the project and she gave us a PDF with the requirements. The design changed several times, but it was easy to keep up because Qt allows rapid prototyping of UIs. Testing the app on desktop is great because you can see how the UI responds to scaling when you resize the window, but occasionally you need to test it on mobile as well. It's super easy with Qt Creator because deploying to a mobile device, it's just a matter of switching kits and hitting run.
With Qt Enterprise embedded, you can use one technology for all target platforms, and you can reuse the same code across everything. This is what Qt is for. We want you to be able to take your software everywhere. So Internet of Things is a big buzzword, something that is used all around when you read about embedded markets and the future they're going. So the markets are clearly going into this direction, and it kind of seems a very futuristic technology or a direction for embedded devices or systems to go. However, Internet of Things is already here today. As an end user, I'm actually really excited about all these cool innovations I get around Internet of Things. I'll show you a few examples that I have in my home that are basically already now implementing Internet of Things. So first of all, that's one of my TVs. I only have two, but that's another one of them. I have two remote controllers for a TV, which is quite much. However, I have 3 kids, which I tell you is too much for 2 remote controllers. So quite often my remote controllers are missing somewhere, and it's usually when you really badly need to change the channel. So what do? I could either search for them, but of course, what I do is I take my mobile device, my phone or tablet, and I can actually today use that as a remote controller for my device. So a simple example of Internet of Things is bring your own device that your end users can have or they can use their own mobile phones and tablets to control the embedded devices you're creating. So my son has one of these GoPro cameras. It's a kind of a camera that you attach to your helmet or bike or skis, and then you go do some daredevil tricks with your friends and put them to internet. So, you know, every parent's dream. It's a killer machine. But as you attach the device into your helmet or bike, there's no display in it because you can't see what's in the camera. So you need an auxiliary display to show the contents of the camera and to control the camera. So the GoPro camera actually has its own wireless network that allows you to connect mobile devices into the network and control them, and then use those as screens for the embedded device. Finally, this is my home automation and security system. And I have a bunch of wireless sensors at home. You know, in my doors, windows, I have a camera, a thermometer, a fire alarm, and all these wireless sensors are connected into an embedded device that then streams the data into a cloud, and I can actually access that data anywhere. So while I'm here, I can check from my phone that if there were any alarms or what's the temperature in my home, or even turn the alarm on or off or trigger it. So this is getting closer to the big possibilities around Internet of Things, that you can have embedded devices and their data accessible anywhere. If we take this away from consumer electronics and things at your home to industrial usage and to different industries, it becomes really revolutionary. So a power company doesn't need to send a technician to my home to read my electricity meter. They can do it from the distance, and it saves them a lot of time and resources and money. In the same way, a logistics company can, in real time, they can track where all their cars are, what is their status, and if they have maintenance needs or anything like that. Or for industrial automation, you can actually control a whole factory and everything inside it anywhere in the world if it's connected to Internet of, or connected through Internet of Things. So if we simplify the concept, it's actually really simple. It's just embedded devices and sensors with unique identifiers being accessible anywhere over a cloud from any kind of devices. But when we look at this from the perspective of software developers and we as the people who need to create these systems, it's not so funny anymore. We actually need to manage a full portfolio of technologies and to set up really complex systems to achieve something like this that the end users are expecting from us. And this is, of course, where Qt comes into the picture. So cross-platform has always been the #1 value of Qt, that we let you take your software where you need it to run. It started from desktop, and then quite soon, Qt has, or for a long time now, Qt has been used on embedded devices. And in late years, Qt has also expanded towards mobile devices. And when we combine these together and reflect them to the Internet of Things story, that becomes the cross-platform story of today. So we want to enable you to be able to take your devices, make them cloud connected, and create embedded devices and applications that run anywhere where you need them to. And let's take a closer look on what we have to offer technically to implement these kinds of things. The core of Qt has always been in the C++ libraries. So when you create an embedded device, there are a lot of these nasty things you need to do in low-level programming, like device driver access. You need to write some sort of a data model, communications over sockets, these kinds of things. And Qt as a C++ library provides a lot of high abstraction level features for all parts of your application contents to use. So you can take, for instance, the Bluetooth API or the Qt TCP socket classes or the sensors API that can be extended using plugins for any other sensors you have. Or as a new mentioned, the Qt WebSockets API, which was released today with Qt 5.3. With Qt WebSockets, you can do real-time connections between devices or applications. So you can actually make a full headless device, a device without a GUI using Qt. But of course, where Qt really shines is when you have a GUI in your device. So for embedded devices, our tip of the spear of the offering is clearly Qt Quick. There are three main reasons why Qt Quick, in my opinion, is extraordinary technology for embedded devices. First of all, you can create beautiful modern UIs that have high performance. It's really optimized to run on devices leveraging all the power of the GPU. Because even though these devices are usually operated by trained professionals, the market requirements for UIs have grown dramatically. You need to have fluent 60 FPS UIs with beautiful animations and of course pinch zooming, because we just really love pinch zooming. Then secondly, the workflow of Qt Quick is really effective. It's designed so that your UI designers and developers, those artists of different areas, can work together with the same product. And this is one of those parts where we will put even more focus in the future to enable a productive workflow where you don't need to have UI designers work with something else and then the developers trying to imitate that with code. That's not very agile. Thirdly, what I like about Qt Quick is that it's fun. It really is fun to program with Qt Quick. And because it's fun, you're productive. You actually can do rapid UI prototyping with Qt, even on embedded devices, which is something quite unheard of in embedded industries. Your deployment cycle, your code or design code deploy cycle is reduced in the bare minimum over the tooling. So you can try out things, you can play around with the UI and do rapid prototyping. Okay, so that's Qt Quick, but the Qt widgets are still there and we're not going to take them away. These form a very important part of our UI offering, especially for desktop development, but also for embedded development. We acknowledge that Qt Quick doesn't fit into all platforms and devices. If your device doesn't have a GPU, you cannot leverage all the power of Qt Quick. Don't worry, then you can use Qt widgets. So these are very good still for creating more static user interfaces for lower level devices. And you still get all the benefits of the cross-platform libraries. Finally, as important as native is, like in the last presentation you heard from automotive industry, that HTML5 is still very important in a lot of industries and in use cases. So we don't want to exclude that. We don't want you to need to make a choice. We want to welcome HTML5 as a first-class citizen to Qt-powered devices through our Qt Web Engine offering. So Qt Web Engine, like you heard, it's going to be available already this week for enterprise embedded. So it's really designed at this point to run fluently on embedded devices. It provides a good feature set of HTML5 and it's optimized to run together with Qt Quick. So you can use HTML5 for dynamic contents, Qt Quick for native UIs, and then you can use OpenGL shaders on top of it to do all kinds of nice eye candy and extra flair. Okay, with Qt Enterprise embedded, the Qt libraries are only half of the story. So we actually want to provide you a full environment, tooling and add-ons that help you reach your markets faster. The cornerstone of this is, of course, the Qt Creator IDE. So Qt Creator IDE over the years has grown into a fully integrated embedded environment. You can design your user interface, you can write all your code there, and then you can directly deploy from the IDE to embedded and mobile devices as well, which is just really something awesome. That whenever you feel like prototyping, you can just change your kit and press play. An important part of Qt Enterprise Embedded is the pre-built Boot to Qt software stack. So this is something that I really recommend you see yourself live. There's actually today in the afternoon, there's going to be another session held by me and Mr. Andy Nichols that will show you Boot to Qt software stack in practice. The idea of the software stack is that you get a pre-built image with the environment. You flash your device or the memory card of it using that image, and you plug it in, and it's running Qt. It's already configured together with Qt Creator, so you don't need to do anything in Qt Creator, or especially outside Qt Creator. You don't need to set up your cross-compilation tool chains and configure Qt Creator to use them. It just works out of the box. So what you can do with this is actually right after installation, you're ready to do a real prototype of an embedded device that you can show to your end users for usability testing. You can show it to your managers to get funding for your internal project, or you can show it to your customers to see what they think about it. And if they don't like it, you can just create a new iteration in a couple of hours. So it's more rapid, it's more agile. This is what we've used to see in web development, but it's still very strange for embedded development. Rapid, agile prototyping. Later on, when you want to productize your device, you don't need to start from the scratch, but we actually provide you full tooling to customize the Boot to Qt software stack to your own hardware and to your own middleware. For embedded Linux, we provide you the Yocto project recipes that you can directly use. Okay, we're also giving you a lot of additional code tools to shorten your time to market. So you can focus on the contents. You don't need to worry about how to write a virtual keyboard. With Qt Virtual Keyboard, we give you a full virtual keyboard solution. It's not only just buttons on the screen, but you can hook it up into a word prediction engine. You can change the keyboard layouts and customize the look and feel. You also get high-level libraries for charting, static or dynamic charting, or 3D data visualizations that work fluently together with the rest of the Qt APIs. Okay, so now you have created your device, and you need to hook it up to cloud. That's where you normally would have hired a team of server-side folks to do their own thing for a few months. With Qt Cloud Services, you get a full portfolio of cloud solutions that you can take immediately into use with your Qt application through the Qt Cloud APIs. So today we have two services available, the Nginio data storage that lets you store your object models and files into the cloud, and then the managed WebSockets that give you a full client-server implementation for the WebSockets API. The cloud services are available for all Qt users, and you can find them under qtcloudservices.com. As a summary, let's take a look at the weather station demo architecture that was featured in the video. You can also see parts of this in the demo booth. We have one weather station at our Oslo office in our R&D premises. That's streaming data to the cloud, so I can see what's the weather like in our Oslo office. It's I think it's pretty cold and dark there now. But I have a device here as well that runs locally, so we can check it out at the booth. These embedded weather stations are like these weather nodes are just embedded devices that have a bunch of wireless sensors connected into them. And these embedded devices running the boot to Qt software stack. So it has some custom low-level code for the device drivers to access the wireless sensors, but that's easy because it's all C++. You can write it in the middle of your Qt application. Then what it does is that it uses the Qt Cloud API to stream the data to the cloud. And from the cloud, you have the clients accessing the weather data in real time over WebSockets or non-real time just using the Ngineo data storage APIs. And these clients run on all mobile and desktop platforms, and they have a scalable UI done with the Qt Quick controls. The same UI runs on mobile devices, Android, iOS, WinRT, phones, tablets, on desktop, and then also on the embedded device. So when we created this demo, we were able to reuse the code, the same code for all of these platforms. Of course, the backend for the embedded device is different because it has the sensors there locally, but it's still using the same technology. So we actually implemented this demo in just a couple of weeks with one technology instead of a whole portfolio of technology and a whole team or teams that handle different technologies. And this is kind of where we want to be with Qt. We want to enable the cross-platform story of today. So you can already look into the future today with one technology, with Qt and Qt Enterprise embedded and the mobile platforms. And yeah, there you have it. So, どうもありがとうございます。
Thank you, Tuukka. That's it for the keynotes today. We hope you have enjoyed them and learned more things about Qt. Please visit the exhibition area, and we are of course available for discussion. Just look at the people with the black shirts with the Qt logo on it. There's also a lightning talk at 12:45 and room 5B. It is about the Qt community in Japan and how to get more involved. Now it's time for a lunch. Lunch will be served on the 5th floor. Thank you. Arigato.